If you are viewing this before you have watched your Algebra 1 lesson on scatter plots, you need to go back and do that. If you have already watched that module, then I'm going to just lead you through a review of the ideas that you saw in there, starting with the idea of classifying a scatter plot. So you can see up here that we have three classifications for a scatter plot. You have positive, negative, or no correlation. So when you're talking about classifying a scatter plot, what you're really saying is if I draw a line through the scatter plot to represent the dots, will it go uphill, meaning it has a positive correlation, downhill, meaning it has a negative correlation, or no correlation means that either the dots make a shape other than a line, or it looks like the dots were just thrown on the coordinate plane at random. So if we look at this first one, number 1, see how these dots are just everywhere? This is an example of no correlation. So the dots are just on there at random. There's no pattern. We couldn't draw a line to follow the pattern. So that's no correlation. If you look over at number 2, if we were going to try to draw a line here that followed the pattern of the dots, it would probably go in there somewhere. So notice that that line goes downhill. So that is telling you that this has a negative correlation. If we move on over to number 3, again trying to do the same thing, if I try to draw a line that represents the path the dots take, that line would probably travel this way. So notice that that line, as you read the graph like a book from left to right, that line goes uphill. So this would have a positive correlation. If we move on down to number 4, so now I'm going to try to not draw the lines for you, and I just want you to envision what's happening. As you look at this from left to right, the same way you read a book, do the lines go uphill, downhill, or are they just random? Hopefully you said that they went uphill, meaning that this would have a positive correlation as well. So notice that 3 and 4 both have a positive correlation, so notice the similarities there. If you move on to number 5, do the dots go uphill, downhill, or just are they in a random pattern? They go downhill, which means that there is a negative correlation. And then the last one, number 6. On number 6, you probably noticed that if you connected those dots, they would make a circle. But that's not really what we want to happen. What we're shooting for on all of these is to be able to create a line. So because I can't make a line that travels through those points in any way that makes sense, this would be a case where there's no correlation as well. So really what you are focusing on is there a linear relationship? Can I make these dots be represented by a line? So we're going to drop down to question number 7 and look at actually creating a scatter plot and then creating a line of best fit from the scatter plot. So we're going to talk through how you would do this. So when you are creating your scatter plot, notice that this one is mapping hours slept and a person's test score. So along the x-axis, you have hours slept, and along the y-axis, you have test score. So what we're trying to do here is we're going to plot these like ordered pairs. So 8, 83 would be one ordered pair. So we're going to plot 8, 83. Then we would have 7, 86, 7, 74, 8, 88, 6, 76, 5, 63, 7, 90, 460, 989, and 781. So as you look at these, do they appear to generally be going uphill, downhill, or have no pattern? Hopefully you're saying uphill, which means that this has a positive correlation. Now our responsibility is to try to draw in a line that goes through the middle of the data. So when you draw in your line of best fit, what you are going to do is connect two of the dots that are on your coordinate plane, and you want to pick two so that it leaves out about the same number of dots above and below the line. So when I say that, don't do this on yours. I would not, for example, want to connect this dot and this dot, because if I do that, notice how I only left out one dot below, but I left out all the other dots above the line. We want a balance. So I'm going to take that back away. So what dots might I connect that I could actually be balanced, leaving out the same number above the line as below the line? So what if, for example, I connected this one and this one? So if I do that, I create that line. And if you notice, I have about 3 points left out below and 3 points above, a couple that are really tight and close to the line in the middle. So if we call that, again, it's called a line of best fit. So if that's my line of best fit and I want to write the equation of the line, we are going to have to first pay attention to what are these 2 points that I connected. So this point here at the bottom is the point that was 4,60. So this is 460. And then the point up here was the point 888. So those are the 2 points that we chose to connect to make our line. Now, if you remember, anytime you write the equation of a line, you have to know the slope. Your formula for slope looks like this when you're finding the slope between 2 points, which is what we're going to do. So for us, that means our slope would be 88 minus 60 over 8 minus 4. So that would become 28 over 4, which is 7. So this line has a slope of positive 7. Your slope is positive because your correlation was positive. Now I need to switch into what we called point slope form when we were all the way back in chapter 6. So for point slope form, you have to know the slope of the line and any point on the line. So that means you have the freedom to choose to use 460 or 888, and it makes absolutely no difference. I'm going to choose to use 460 because that involves smaller numbers, making my task easier. So y minus y1 is the y part of the ordered pair you're using. So for us, that would be 60. Equals m. Remember, m stands for slope, and we found out that the slope of this line was 7. And then x minus x1, that's the coordinate, the x coordinate from your ordered pair. So for us, that was 4. So this is the equation of your line of best fit in point slope form. If we want to put that into slope intercept form, remember slope intercept form is y equals mx plus b. So if I want to get it to look like that, the first thing I need to do is I need to distribute this 7. So y minus 60 would equal 7x minus 28. And then I need to get y by itself. So to do that, I'm going to add 60 on both sides. And when I add 60, I end up finding out that the equation of my line of best fit in slope-intercept form is y equals 7x plus 32. So this would be the equation of your line of best fit, which is something that your Algebra 1 teacher is going to ask you to find. So I have an assignment posted for you on Canvas. You're going to need to go and complete that assignment for today's class. And then tomorrow we will again talk about scatter plots, and I will focus on what you did really in the second half of your Algebra 1 lesson today. Have a great day.